be using in Python, which is called Pandas. To not spoil anything, I will let Jack continue here. Thank you.
And hello, everyone, and welcome. Happy Monday. Hope you're having a great start of the week. And yes, today we are going to dive into Pandas. So just to give you a little bit of an idea, so it turns out, especially when it comes to everything that has to do with data analytics, that we like tables. Just like we worked with Excel, that's a table. We worked with SQL, that's a lot of tables. And of course, in Python, we needed a table. So originally, a group of people who were doing econometrics and knew how to code got together and started figuring out how do we do this? Because they had the same tools that you do so far, lists, they had dictionaries, etc., but none of them were actually doing the same thing as a table. So they wanted to build something that was similar to it, and they did. And eventually, they built this particular library called Pandas, which stands in particular for Python Data Analysis. And the whole idea is that we would be able to upload all kinds of tables, doesn't matter which format, and we could actually use it just like we use an Excel sheet, but through the power of Python. So the important thing with this is that we can now upload even an Excel sheet or a CSV file or any kind of file, even code, and transform it into what's called a data frame. And a data frame at the end of the day is mostly just like a table. So it's a very fancy name for a table, but it is called a data frame because think about it. It's a frame and it's filled with data. And we can actually use this to manipulate our data very quickly and very efficiently. And that is exactly what we're going to be doing today. So the first thing, let's talk about the two particular structures, just like lists, just like dictionaries, that we now get access to using the Pandas library. They're called a data frame. So again, this is the one that works just like a table. And then there's a series. So a series is a list of indexed items. So think about it as a list, but it actually contains the index inside of it. So instead of just going, item 1, item 2, item 3, you have 1, 2, 3, the numbers 1, 2, 3, and then whatever items there are. So in other words, it's numbered, just like any column inside a data frame or inside a table. So remember that what happens right here is that we're trying to bring the functionality of tables into Python. So tables are very, very useful for us. And they're useful mostly because we can store a lot of data in a very logical format. So imagine how much more powerful it can be. Doesn't matter if we're talking about a few hundred rows or a few million rows, how powerful if we can actually do everything we can do with a programming language like Python, functions, for loops, etc., with the tables that we're already used to working with. A few very important things about it. If we're actually using Pandas, code tends to work a lot faster than if we're using any other kind of structure. And also, we can actually do a lot of very interesting stuff with a lot less code. So those are two of the most important reasons why we're going to use it. Now, coming back again, series. A series or a series object is going to have one single column of data. So whatever column you can imagine, just imagine the whole column is one series. And a data frame, on the other hand, is a table. So it's a two-dimensional object. It has columns which are named. So this is the big difference between columns in Excel. Excel, if you remember, you have column A, B, C, D, E. They're sort of indexed as well. In Pandas, they have names. So whatever name we give them, so for example, name, first name, last name, address, etc., each of them is a column, and we actually use that name as the way to identify that particular column. And that becomes really, really important. So think about it like this. Imagine this is a table for anything you want. So we have, for example, let's say this is a person. So this is the first name, this is the last name, and this is the address. Okay, so those are the names of the columns. And then we have the rows, which are indexed, of course. And then inside each of these points, just like in an Excel sheet, we have the specific data. So the first name column should have a first name, the last name column should be filled with last names, and the address column should be filled with addresses. So again, just think about it as a table, and we're going to see that it actually prints out as a table as well. Now, if we actually slice data frame, what we get is a series. So just imagine that you have this series. Again, these are the first names, and I just want the first names of everyone. So I'm going to slice this. Now, instead of just getting a list of names, I actually get this. Okay, I get the row number and the name. So if I cut one column, this is what I should get. I get the row number and whatever data is in that column. I do not get the name of the column. So that's the only thing. There's no column names, but we can give series a name. We could actually, say first names, and then that's the variable for this column. And that would create a series object. But most of the time, we're going to be working with the whole table. And you're going to see that Pandas makes it very, very easy to do it. By the way, a whole data frame object, not just a series, can also have just one column. So we can actually build a data frame that has only one column. And the only difference, it's going to look exactly the same as a series, with the exception that it's going to have a name here. So up here, you're going to get a name. Whatever that column name is, it's going to appear. That's the only difference. All right. So the first thing, if we want to use Pandas, is we need to load the data into our data frame. And there's tons of ways to do it. We can actually code it. We can actually upload all kinds of tables like Excel files. But the most common way of storing data in tabular data is in comma-separated values, or CSV files. You can actually, with Excel, you can save a file as CSV. Now, CSV, all it does, and we use it because it saves a lot of space, is that all of the information from a table gets saved in comma-separated items. So, for example, you get something like this. The first row, in this case, the name of the columns, gets stored in the first row, and again, separated by commas. Then the first row of information, again, separated by commas, cow, farm, white and black. Then the second row, again, just the information, cow, house, Tony, etc. So all of this information becomes this shorthand kind of thing. So this is what we're going to be working with most of the time. So instead of having an Excel file, we're going to have a CSV file. And this is all we need to know about the CSV file. So the first line is just the name of the columns, and then is the data that goes into each of the rows. Now, it turns out that it makes it really, 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 Pandas makes it really easy. So the first thing we want to do, of course, before we load anything up, is import Pandas. And just because it makes our lives a lot easier, we also give it an alias, just like you did with NumPy. Remember, we import NumPy as NP. In Pandas case, we import Pandas as PD, right? Just to make our lives easier. So we don't have to be writing Pandas all the time. And after we import it, we can actually just load it by using the read CSV function. So PD, I'm calling the Pandas library, dot read CSV is the read CSV function. And inside the brackets, the only argument I need is the file path as a string. So where am I going to find this file? And once it's done, Pandas is going to take care of everything. So that's what we're going to do. So as you can see in my first cell in this Jupyter notebook, I have import Pandas as PD. So that's the first thing it's going to do. And then it's going to load the CSV file as a data frame into a variable I'm calling df. df, short for data frame. Again, you can name it anything you want. We just want to remember that every time we're working with a data frame, we're going to have to give it a name. So in this case, I'm just going to name it df. So when I run this, by the way, you can run the cell by clicking here, just a quick reminder, or by hitting Shift Enter when you're in the cell. So I'm going to hit Shift Enter. And as you can see, this says 1 over here. This means that the cell already run. Of course, there's no output because I'm not printing anything. But now I already have a variable called df, which has this file as a data frame. So if we want to inspect it, which is the case I'm going to do right now, we can actually use the head method. So the head method by itself, so df, I'm just calling the data frame that we built, and then .head for the method. And I can leave it blank because there's a default, and the default is 5. So it's going to print out the first 5 rows of our data frame. And when I do this, you're going to see that it's going to look just like a table. So I'm going to hit Shift Enter, and there's our first 5 rows. And as you can see, it's just like looking at any table in Excel. And here we have the index. And of course, we're working with Python, so we start with 0, because that's how Python works with indexes: 0, 1, 2, 3, 4, etc. So as we can see, and by the way, if you want to look at more rows, you can. So for example, I could actually, instead of 5, I can say head and then 10 as an argument, and that's going to show me the first 10 rows. If I want to see the last few rows, I can actually change head for tail, and it's going to show me the last 10 rows of data. So I'm going to do that, and there we have it. I get the last 10 rows of data. All right. By the way, just because I see it on the chat, if you try to run anything before you run this cell, nothing's going to work. Because remember, this first cell is the one where we are defining the variable df, and we're creating that data frame. So until you do this, nothing else is going to work. All right. So, and by the way, yes, as I mentioned, you can actually do the tail or the head with any number of rows, and it's going to show you. So for example, the last 5 rows, we have 70, 71. So as we can see, if this is 74, it means we have 75 rows inside our data frame. All right. So just let me go back to head. And let me move it, just the first 5. So just to have a little bit of an idea of what we have, what kind of data are we working with. So first, it's talking about the model. So Caracal, Lightning Bolt, Sand. So these are models of watches, okay, just in case. These are names of watch models. Then we have the name of the store. So which store carries that watch? So we have Watches Unlimited, National Trader, Super Deals, etc. This is the condition of the watch. This engagement is telling us what the engagement from the website is. I mean, how many people look at that watch. And finally, the price. So this is the price of each particular watch. The whole data set, as we sort of see if we look at the tail, is 75 rows. But let's actually look at the data set a little bit more and understand how much, what all the stuff that we can do with Pandas to actually analyze our data better. So the first thing is we can actually use this method called .info. So .info is going to give us a little bit of information about the whole data frame. So it's sort of a little bit of a cheat to get just a little bit of information very, very quickly. So I'm going to run df info. So again, df or whatever name of my data frame, just .info and open brackets. I don't need to put anything in there. And I'm going to click Shift Enter. And here it's going to give me some information. So it's telling me the class of the object. In this case, it's telling me that it's a Pandas data frame. Range index 75. So it's telling me that it's 75 rows. Again, it goes from 0, index 0, all the way to index 74. It's telling me how many columns it has. In this case, it has 5 columns. And then it's going to give me some information about each of those columns. And this is where it becomes really important when we're doing data analytics. So it's telling me that the first column is the model, and that it has 75 non-null values. So this is important. If we have 75 entries in total, and this column has 75 non-null values, it means that apparently we have no missing data. So that's important. And the same thing for all the other rows. So we have store, again, 75 non-null, condition, 75 non-null, engagement, 75, and price, 75. On the other hand, it's also telling me a little bit of the data type. In this case, it's telling me that model, store, and condition are objects. In this particular case, this is telling me that they're strings. And then engagement and price, it's telling me that they're floats. Now, particularly float 64, don't worry about how it's done. It's a very lower end about how information gets saved. And 64 just means 64 bits. But the important thing is to know that these are floats. All right. Finally, it's telling me that what D types we have. We have, again, 2 floats and 3 objects. And so in this, object can be other things apart from strings, but in this case, they're strings, like in this very particular case. All right. But generally, object is something that's not a number. That's the most important thing. And finally, it's telling me how much memory is needed to have this data frame. So in this case, about 3.1 kilobytes. So again, that's not a lot of memory. Because again, we have a very small data set in this case. Now, with info, we get some basic information. We can also look at other things like the shape. So we can use df shape. And when I run it, and look at the fact that shape doesn't use parentheses, which is interesting, but that tends to happen. And it's telling me that it's 75.5. So again, 75 long by 5 wide. So in other words, it has 75 rows and 5 columns. Drew, just to answer your question, yes, object. So the important thing, object can be anything that's not a number. So most of the time it's going to be strings, but it could be something else. So for example, if it's 1 or 0, it would say bool for Boolean. But yes, just think about object, about anything else that's not a number. And 99% of the time, that not a number is going to mean a string. But there are a few exceptions. They're just, edge cases most of the time. All right. So with the shape, again, we get some information. And if we just wanted to look at particular things, like, for example, how many rows do we have? We can just do df shape 0, because this is sort of a tuple, so we can index it. So these are 0 gives me the number of rows, and 1 gives me the number of columns. So again, all I'm doing, by the way, is that df shape is a tuple. So I can just use the slicing method or index method, just like we do with lists. All right. So in this case, all I'm doing here is printing out in a nice way how many rows and columns we have. So rows is going to be df shape 0, and columns is going to be df shape 1. And then I can print out nicely. There are X amount of rows and columns. I'm using the dot format method, so I can use rows and columns here because I created them up here. Again, just a fancy way to do a print statement. So there are 75 rows and 5 columns. Okay. So we know we know the shape. We sort of know the information in our data set. But I also want you to think that even though we're using a small data set, most of the time we're going to be working with very, very big data sets. So in other words, thousands of rows, maybe hundreds of thousands, or even millions of rows. So think about how much time you can save by using a lot of these functions, especially this next one. So we can actually check cell by cell in our data frame whether there's a null value. In other words, are there any values missing? So the first way to do this, not the best way, but the first way to do this is to call the isnull function. So the isnull function is just going to go through every single cell in our data frame. And if it's empty, if it's null, it's going to say true. If it has something, it's going to say false. So right now, again, this is going to get caught over here just because Jupyter does this, so it doesn't have to print large things. So it's sort of telling me that it's filled with false. So all this is saying is that in row 1, there is something there, and there is something there, and there is something there, because I'm asking it, is there a null value there? And it's all false. Now, this, if I have a data set with thousands of rows, this doesn't make sense. It's going to take a long time. But the cool thing is that Pandas gives me more methods and more functions that I can just stack together. So I'm going to use 2 functions to get a summary. The first one is .isNull, because again, this is going to tell me, or it's going to do false for any null values it finds. And then I'm going to mix it with the .any function. So the cool thing with this is that it's going to tell me how many values or where there are null values inside of my columns. So I'm going to run this, and it's going to go through the whole column, and it's going to check if there are any false values, any true values or any null values inside a particular column. So this is going to make my life easier. So think about this. Model, it says false. It means that there are no null values. Store, again, no null values. Seeing all false in every column is actually telling me that I do not have any missing information, or at least any missing values in my data frame. And we're actually going to even do a little bit more of a mix in just a bit. So other things that we can do with another wonderful function is the columns function. So sometimes we may have, so right now we only have 5 columns, but there are some data sets that can have tens, hundreds, some even thousands of columns. And sometimes I just need to know what they are. So by calling df columns, I actually get a list with every single column in my data frame. So this is just telling me what are the columns. So model, store, condition, engagement, and price. If we go up here, these are the same ones. That's it. And if I know the name of a column, that's how I can traverse my data frame. So if I want to see the values in a particular column, I can just, so this is for me one of the coolest things about Pandas data frames, is that I can just put in square brackets the name of the column I want to look into. So if I do df condition, it's only going to pull out the information for the condition column. So again, I'm getting this now is a series. Remember, we talked about series at the beginning. So I get the row number and then what the value is in condition. So new, like new, very good, etc. And I can do the same thing for anything. So if I just change df condition to df model, I get the information from model. And this actually makes my life a lot easier because I don't have to know what number the column is. I just have to know its name. And the other great, by the way, great and very, very, very important function is the value counts. So one of the most difficult things of working with information or data when it's in a big data frame, when it's in a table, is trying to figure out how many different values we have inside one particular column. So some columns, so for example, if we're talking about first names, we expect to have a lot of them, same with last names. But if we're asking people, for example, how many children does someone have? Well, those values can vary, but we're not expecting an infinite amount of values. If we're asking people, with what kind of vehicle they know how to drive, or something that only have a certain amount of values, there's only going to be those values within the data set. So value counts is actually going to help me figure those out. So I'm going to run df.condition. So in this case, I'm doing a little bit of a change. See that this, initially, I was doing condition like this. It turns out that I can just do a dot and do the same thing. See? So I can actually access a particular row either by putting it as a string inside square brackets, or let me actually get another over here, or I can do the same thing by just doing df.condition. And again, I don't have to write it as a string, just straight out, and I get the same result. So in this case, I'm going to do df condition, and then I'm going to do value counts. And this is what I'm going to get. So I'm going to get a few things. First, these are the options. So the only options in conditions are new, like new, good, very good, and fair. And it's also telling me how many rows have those values. So I have 15 rows that are new, 15 rows that are like new, 15 that are very good, etc. And I can actually do the same with all the other, with any other column. So for example, if I wanted to see, by the way, it works the other way as well. If I do stores dot value counts. Sorry, no, my bad. It doesn't work with stores. Dot stores. Is it just store? Yeah, it's just store. So it works either way, yes. So it's either store or like this, store. So it's telling me that I have 3 stores: Watches Unlimited, National Traders, and Super Deals, and we have 25 of each. And finally, I can actually do one more. I just forgot what the name of let me just go back to not engagement model. We can actually do the same thing for our model. So df.model.value counts. So this is going to tell me, again, we only have 5 models. And it's going to tell me 15, how many of each there are. So that's interesting. So it's not going to count null values. If there's a null value, it's going to ignore it. So value counts is going to say Caracal, lightning bolt, sand. So what the values it finds and how often it finds them. That's why we have the isnull. That's the important thing. So we use isnull to figure out if we have any missing information or any missing values inside a particular column. Okay, questions so far before we get into sorting and filtering? All right. So you could do, I believe you can do, that's a great question, by the way. Where did I go? .any. So we could actually, if I'm not mistaken, go df.model. So if we found in this, so we use the isnull any, and if one of these, let's say model came up true, okay, then we could actually filter that. So df, let's say df model dot, not dot value counts, df model dot is null. Let me just check one thing. Is null dot, I think we can do value counts. So we can just keep stacking, and no, we can do it like this. Let me just check it like this. df model models. Dot model. I'll find out for you and I'll let you know. But yeah, there's a way to actually count them when we start filtering them out. Yeah, we can filter out and we can definitely count them. Thank you, Cassie. Yes, Cassie, sorry. Thank you for that. All right, so let's start sorting the values and see what we can do, because a lot of the time we actually want to be able to filter to find just some of the stuff that we have inside our data frames or our tables. So we can actually sort it in any way we want and from any column we want. And to do that, we're actually going to use the sort values function. Now, because I don't want to actually change my original data frame, before I do it, I'm actually going to create a new variable called df sorted. So this is going to be my sorted data frame, not the original df one. So what I'm going to do is I'm going to call the sort values. The first argument is what is the column that I want to sort by. So in this case, I'm going to sort by price. And the second one is whether I want it ascending. So again, ascending false means that it's going to be descending. Ascending true means it's going to be ascending. And then I'm just going to check at the first few. Let's actually do 10 rows of my df sorted. So here's my first 10 rows. I'm sorting by price. So as you can see, I get the highest price first because ascending equals false. So it's going to be descending. So my top value first and my lowest value afterwards. If I wanted this to be ascending, in other words, from smaller to bigger, I would just change this to true. And I get the smallest price first. So the important thing is that you're going to sort by one particular column. So you need to pick which column it is. And we can do it which any way we want. Of course, it's going to change depending on the kind of data that we have inside of our data frame. So again, this would be with false, it would be descending, and with true, it would be ascending. Let's actually do 10 as well. I'd like to look a little bit more data. All right. Now, very important before I move on to that, we can actually, here's a question. Do you think we can sort by model, for example? So model's not a number. So what would happen if I run model? Well, let's see. Do I get an error? And no, it turns out it does. What it's going to do, it's going to order them in alphabetical order. And again, if I do ascending, it's going to start with ABC. If I do false, in other words, descending, it's going to start with the last with Z, but in this case, my lowest one is tempo. So that's it. We can actually organize by any of the Z or Z. Yes. We can organize by any of the columns. So again, if it's a string, it's going to be alphabetically. If it's a number, it's going to be numeric. That's it. So for example, I could also do engagement. And yes, I'm going to keep ascending false. So I want to see the largest engagement first. And now I'm organized or arranged, sorted by engagement. And that's it. We can actually do it any way that is convenient for us. Now, sometimes we actually want to, and this is one of the best things about Pandas, sometimes we actually want to sort things not by one column, but by two columns, because we know that there are going to be some ties. So for example, let's say that I wanted to see if the condition, or sort by condition, or sort by engagement, and then by price. So it turns out that Pandas actually allows me to sort by any number of columns I want. So it's going to take the first one and going to sort by that one. And then if there's any ties, it's going to sort by the second one. And if there are any ties there, it's going to sort by a third one, fourth one, etc. Now, the only thing is that we need to change how we use the function, because it only allows you to put one argument in each place. So this should be one argument, and this should be one argument. So to solve that, we can actually pass lists instead of actually just the one item. So the way to do it is we're going to use sort values, but in this case, we're going to pass a list with the names of the two columns, and then we're going to pass the ascending argument with a list with two booleans, either true or false, whether we want it in ascending or not. So again, here's an example. So we can do df sorted equals df sort values. I'm passing a list, so I want to sort by engagement first. And if there are any ties there, then I want to sort by price. And in this case, I want to be descending in engagement and ascending in price. So this is what I get when I run this. So just in case. So again, it's going to take engagement and it's going to be descending. So again, it starts 86, 85, 85, and so on. But if there's a tie, like we find here, let's actually point it out. So we have a tie over here, as we can see. So we have both our 83.164557 in engagement. So now it's going to take the second item on my list, which is price, and it's going to sort it in ascending order. In other words, the lowest price first. So again, engagement, highest engagement first, and lowest price first. So this gets sorted before this one. Here we have another tie. By the way, this is a bigger tie. We have three items. And again, now it gets sorted by price in ascending order. So that's how we can actually keep sorting or tables depending on how many columns we want to sort. And this is a very cool thing because this is actually not as easy to do with other tools as it is with Pandas. All right, questions about sorting? Yeah, so like SQL, so one of the important things is that the people who built Pandas actually wanted to have a little bit of the functionality that you have with manipulating tables from SQL. And by the way, a lot of the time, if you're working with Pandas and you're working with databases, you actually download you do your query, you download that query directly into Pandas DataFrame. But that's something for the future. All right, so let's move on to filtering. Now, filtering is also very cool and simple with Pandas, because that's the way that the people who built it decided it should be. So you can actually figure out what conditions you want to target. And the cool thing is that you can just do it by naming, like we know we can figure out whatever filter we want by picking whatever condition from whatever column we want. So in this case, we start with the data frame, and then in square brackets, we're actually gonna tell from this column, I want this particular condition. So whatever exactly it is that I want. So think about it like this. I'm gonna do df for my data frame. This is the one that has all of the watches. And then what I'm asking it to do inside these first square brackets is that in the model column, I want only lightning bolt. So it has to equal lightning bolt. So in other words, what I'm doing here is I'm asking to see all of the watches that have the lightning bolt model from our data frame. So when I run this is what I get. So as you can see, I get the 15 watches that have the lightning bolt model. All right. So again, data frame, then the column that I want from that particular data frame, and then whatever condition I want to actually run for the filter. And that's all I get. I only get all of the information already filtered for me. So Ram, that's interesting. What kind of project or what kind of scenario we use Pandas? So for example, anything that has to do with machine learning, you're going to have to use Pandas. So we transform the data into a Pandas data frame, and from the Pandas data frame, we run machine learning algorithms. That's common practice. So anything that you want to do with tables in Pandas, in Python, you're gonna be using Pandas. And machine learning, deep learning, all of that, they use a lot of tables. But we'll talk more about that next week, by the way. So very important whenever you're doing filters. Both, yes, you can filter by numbers, and we'll check that in a bit. You can actually let me just. So yeah, before that, so you can actually say, let's say price, and I'm not going to go equal is bigger than 1,000. So, just like we do all of the filtering, and here I'm getting all of the watches that have a price over 1,000. Actually, let me do, just so I don't get that many, let me get 4,100. That's a lot that have more than 4,100. Yeah, actually, let's do cheaper watches, less than 500. There you go. There's only 3 watches that are less than 500. So yeah, you can filter by numbers. It just changes. So I'm just asking that the price, which is a numeric column, has to have a certain particular number. Yeah, some of these watches are crazy expensive. And it's interesting. So if you really like watches, you might actually recognize some of these brands. I'm not a watch person, so I know if I ever get a watch, it's going to be something, something like a Fitbit or something like that. All right, so we can actually not just filter by numbers or a particular column and a particular condition. So the important thing, by the way, let me just go back here to what we had before. So we had the lightning bolt in model. So very important that both the name of the column and whatever condition you're putting, it has to be exact. There's no like here, like we have in SQL. You can't do it a like. That's a whole other lesson. So you have to be very precise. So you have to know exactly what you're putting in here, both the name of the column and whatever condition you're filtering. If it's numbers, not that big of a deal. So the other important thing is, as you can see, here I'm not saving things. See, remember that when we were sorting, I actually created a new variable called dfSorted. We're not doing that here because filtering does not affect the actual data frame. And yes, Gautam, that's my next part. So how do we filter by multiple conditions? So we can also apply multiple filters. It doesn't matter if it's numerical or categorical columns. And all we do is by using different kinds of operators. So if we want 2 conditions, for example, so I'm going to do, original data frame, and I'm going to, so DF filtered in this case. So we get the column name and the condition. And as you can see, we're using round brackets. And then I'm using the ampersand saying, and just that's like the and in SQL. Then the data frame column name and whatever the condition. So for example, if this was a numeric one. So in this case, I'm doing DF filtered. So I'm saying a new variable just to make my life easier. Then it's going to be the data frame, and it's going to have condition 1 in round brackets. So my first condition is that the condition column has to be new. And using the ampersand, the secondary condition is that the price has to be less than $600. And then I'm just going to check the head, and I get only 4 because there's only 4. So in this case, in new condition, there's only 4 watches under $600. And that's how you do multiple conditions. And you can just keep adding conditions, by the way. Inside these square brackets, you can just keep doing and, etc. And by the way, if you look for a cheat sheet, you're going to have ORs. You have symbols for ORs, symbols for XORs, etc. So you have all of the same kind of systems, the same kind of possible logical conditions that you have anywhere else in Python. Is Panda easier for making dashboards? It depends on the dashboard that you're making, but it would take some other software. So for example, if you already have your data set in a CSV file, you might actually want to do it in Tableau, which is going to make your life a lot easier. But Pandas is a lot easier to actually do some analytics, run some very quick visuals, and very important, it's vital for machine learning, incredibly vital for machine learning. All right. So yeah, in this case, and not a comma. So and the ampersand is telling me that this condition has to be true, and this condition has to be true. So again, in this case, because remember, we can also do ORs, we can do NOTs, you can do all kinds of things as well, but you have to separate them by whatever operator is going to give you what you need. So in this case, because we want both conditions to be true, you need to use the and for ampersand. All right. Questions so far? All right. So it's going to be fun. So aggregating data. This is the other part where Pandas shines. So it makes our life a lot easier to get some of those aggregates, some of those very important statistics that we need to run at the very beginning. And you can actually obtain very, very, very quick statistics without having to do a lot of code. So for example, mean, median, and mode, minimum, maximum, count, and sum, we just have some functions that we can simply use. So for example, .mean is just going to give us the mean of whatever column. So in this case, I'm going to go into the price column, so df.price and .mean. So I'm just getting what is the mean for the price, what is the average price. And if I run this, boom, I get 2,277. So again, one line of code, I already get some interesting statistics very, very quickly. So median. So again, if I want to run the median, I just use the median function, df.price, and then .median to get that particular value. So here's an interesting statistics question, just to remember how statistics works. In this case, if we have an average of 2,277 and a median of 831, is this a normally distributed data set or is it skewed? And if it's skewed, to which side? So I want you to think about it like this. Remember, let's see if I can draw it over here. We have a distribution. So it's saying it's skewed towards the most expensive. It skews to have some very high outliers, skewed, but I don't remember how. Yeah, skewed towards the pricier side. So here's the thing. In a normal distribution, you would have your mean over here and your median practically in the same place. So mean and median should be about the same. It can vary a little bit, but they should be about the same. Now, the question is, when your mean is over here and your median is around here, what kind of skew do you have? So remember, so let's remember our skews. So this is a very badly drawn normal distribution, then this is a right skew, okay? If the tail goes, so it's all about the tail. So if this would be a right skew and this would be a left skew. So again, towards where the tail is. So the question is, so here's my thing. If this was a left skew, the median would be around here and the mean would be around here. Okay? So what would happen is just think about where the mean is pulling the median. So in this case, as you can see, the mean, or in this case, yeah, the mean is pulling the median towards the left. So just think about where the median is in regards to the mean. So let's do this again. So if we have 2200 is the mean and 831 is the median, all you have to think about is where is this? So where this is regarding the median for the chart lovers. So in this case, so again, this value is to the right of the median. So this would be something like this. So the median would be here and the mean would be here. So again, if the mean is bigger than the median, you have a right skew. If the mean is less than the median, you have a left skew. And that's a very, very quick way to learning and to knowing. And by the way, if you ever apply for a job that requires statistics, that is going to be an interesting question that you will probably get asked. All right. So let's actually do the mode. We also have a mode formula, but this one's going to be a little bit different, and we'll figure out why in a bit. So when I run the mode function, I actually get 0, 831. So any idea of why, any idea of why I'm getting this 0 over here? Because I didn't get it here and I didn't get it here. So why is for the mode am I getting an indexed value? How many modes can a distribution have? So let's think about it like this. Imagine that we had this list. LST equals, let's do 1, 2, 3, 4, 4, 5, 6, 7, 7. All right, here's a question. What's the mode of this list, of this data set? Thank you, Drew. Yes. So it turns out that the mode is 4 and 7 because those are tied for the highest value. So it turns out that you can have more than one mode. You can have, so if there's 3 values that are tied, you have 3 modes, etc., etc. So because you can have more than one mode, then the mode function actually creates an indexed list or a data series, just like we had before. So it's telling me that there's one value, which is 831. If there were 2 modes, it would say 0, 1 value, and then in number 1, the second value. Then index 2, the third value, if there were more. But in this particular case, there are no more. And that is the reason why we actually have the mode is a little bit different than the rest. All right. Finally, let's talk about the min and the max. So these work exactly the same way as we were using in lists, min and max. The only difference is that we use the dot max and dot min. So if I wanted to know the minimum price, I just use the maximum price is 4,308 and the minimum price is 489. Now, a lot of this information we can actually get, which is interesting. We actually have one more function that gives me a lot of information about our data frame. So if I wanted to get a lot of the information that we already got, not all of it, but some of it, we can actually use the describe method. So if I use on my data frame the .describe method, I get all of this information. I get the count. So this is interesting. So the count of non-empty values in each column. This also helps me figure out if there are any null values. The mean, what's the average for each column? Again, for the numeric ones. The STD, the standard deviation, very important. Minimum value in each column. It also gives me the percentiles for 25%, 50%, 75 percentile, and the maximum value. So I'm actually going to run it, and we're going to see. So again, I only get the information for the numeric columns because those are the ones that have all of that information. I get a count. And again, the count is non-empty values. So I have 75 in each, which we already knew from before. We get the mean of the engagement and the mean of the price. We get the standard deviation for both the engagement and price. And as you can see, this is a large standard deviation, meaning that there's a lot of variability between the values inside the data set. We get the minimum values, the percentiles for 25, 50, and 75%, and of course the maximum value. That very quickly, and again, one line of code, and we get all of that information. Now, the interesting part is that we can actually get some statistics on the non-numeric columns. And the way to do that is to include object. So what it's telling it is all of those object columns that you have, please include them. So in other words, use those instead of my numeric. So when I do this, it's going to give me, again, some information. It's going to give me the count. It's going to tell me how many unique values there are. So in other words, how many unique values, specific values are there on that particular column. Top, so it's going to be the top category. If there's ties, like in this data set, it's not going to work as well. And the frequency of the top category. So I'm going to run this. And as you can see, now I'm getting the model. It's going to tell me the count, 75, 75, 75. Unique, there's 5 different models, 3 different stores, 5 different conditions. And this one is just going to pick one almost at random. So you might actually get, let me just check it out. Well, you're probably going to get the first one. It's just going to pick the first one because we already know that each of the models has 15 watches, that each of the stores has 25 watches, and each condition has 15 watches. So when there's ties, it doesn't work as well, but most data sets, it's going to give you what the top category is. Great. So do you have any questions? If there's no questions, give me a thumbs up and we'll take our 10-minute break. But I'll give you a chance to see if there's any questions first. All right. So let's take a 10-minute break. Go stretch your legs, grab a snack, grab a drink, and I'll see you in 10 minutes to start doing some groupings.
Okay, perfect. I will have the timer on display and play some music for you all, okay? Let me pause the recording here. Okay, perfect. We are good to go.
All right, and we're back. So now we know how to sort data. By the way, just to answer a question, the way to count how many null values you have in each column, it was sum, not value counts, using the isnull combined with the sum function. So if you do that, you get this answer. So again, it tells you how many values there are, how many null values there are in each column. In our particular data set, we have none, which is a good thing. But this is a very fast way to figure out where we have null values and how many, if there's too many, and then we can decide what to do with them. All right. So to group, one of the other things that we want to be able to do is group our data. So this is something that we do a lot in SQL. You already done it. Remember the group by statement? This is the same thing. And interestingly enough, in Pandas, we have the .group by method. So all that's going to happen when we do this is that it's going to loop through the whole data set, and it's going to group the values depending on what we tell it to group it by. So it's going to give us some aggregates, just like exactly the same way we did with SQL. So what we're doing is we're just splitting our data set into smaller chunks. So for example, if we had this, let me open up my annotate. If we had this table, And in this case, we wanted to group by something in particular. So for example, we want to group it by the values in the foo column. We are going to end up with two different groupings, one for all the values of foo and one for all for the values of one, and a second one for the values of two. And that's how the group by works in general. So in other words, it allows us to group by depending on whatever needs we have for a particular analysis that we're trying to run. So let's think about the particular things that we want. And again, if we want to do aggregation of anything, and we can do it by pricing, by engagement, anything that has either a numerical value or a non-numerical value, it doesn't matter, but we can do the grouping, and then we can get some aggregates running. So in this case, the first thing that we're doing is we're going to create some groups, and we're going to group our data set by model and condition. And then I want to get the mean price. So again, what I'm doing is I'm creating a new variable called groups, and then I'm running my df group by. And again, it takes one argument. And because I want to group by two different conditions, I actually put them into a list. So model and condition. And then I'm going to use that in particular because this is a new data frame, the one that's split, just like here. And then I'm going to get the mean of the price. All right. So when I run this, this is what we were going to get. So again, it's going to group by first the model. So I'm getting the model first, and then the condition, very good, like new, very good, etc. And that's going to give me the mean or average price for each of these groupings. So for example, the average price for a sandwich new condition is 543.5. All right, that's the average price. I don't know how many of them there are, but that's how you start doing the conditions. If I only want to group by one particular, so for example, if I wanted to group by just the model, then you don't need the list inside as an argument. So again, this is the average price for each of the models. So Caracal 1770, Clepsydra 2517, etc. I can also do by condition if you only want to group by condition, or again, I can actually let's see. We can do by condition. If I wanted to do more than one, I can do by condition, and let's say store. So again, this is going to give me the store and then the average price depending on the condition of the watch. And again, I can add more. I could definitely add here, what was it? Condition and model. It's just going to become more interesting. So again, it's going to tell me national traders, condition fair, and the models that it has, etc., etc. So we can just keep adding and adding depending on what you need to do. So questions about grouping, because I'm about to give you a little bit of an exercise, and it has to do with groupings. And in the meantime, because I see a couple of people typing, this is something cool that we can do. So for example, let me actually do that. So if I want to see what groups were built, so for group, in groups, I can print the group, print group. So going back to our, and here it's going to tell me all of the groupings that it's doing. So again, national traders, fair. This is group one. National traders, good. National traders like new, and so on and so on. So because we use two conditions, it's creating a lot of groups, right? How can I add the column header? Like, you mean how to add the price over here? Good. That one's a hard one. So in this case, you cannot. You would actually have to transform that into something else, but it's not going to allow you to do it because this is the answer to this question. So this is the mean price for each of these groupings. So I could actually change this to engagement, and I'm not going to get the header. It's not going to give you the header just because all it's doing, it's giving you the headers for the groups, but it's not going to give you the headers for the result that you're looking for. So it turns out groupby is more similar to groupby in SQL because you're going to see that we can actually pivot tables in just a bit. Yes, but yeah, you could also think about pivot tables because in Excel you can actually build tables like this using pivots. Yeah. So yeah. All right. So here's the question for now. Here's a little bit of an exercise. I want you to repeat the group by aggregation above, but only group by model. So we're going to do the same. We're going to group by model and get the average price instead of grouping by model and what did we do? Model and condition, just by model. So when you're done, yep, feel free to share the result. So as you can see, because I'm getting a lot of answers very, very quickly, group by is fairly simple to use. So this is the most important thing. So this is something that happens whenever you learn Python. At the beginning, it's like everything takes a long time to build. But once you start learning the libraries and learning all the logic behind it, then you start using those libraries. It makes your life a lot easier because then you don't have to code everything from scratch. So I'm going to do this in this case. I'm going to do groups 2 because I already have my groups 1 or my groups. And again, so in this case, just going to do df.groupby, group by. And in this case, I'm going to just use model. So again, it'll work if you do it like this, or it'll work if you put it in a list. So it doesn't matter whether you put it in a list or not. As long as it's 1, it's going to work. So I'm going to group by model, and then I'm going to get groups 2 dot mean, because that's exactly what price. I forgot the price. Groups 2, I want the mean of the price because there's also the engagement. And I want to get the mean, and this should actually give me the result that you all got incredibly quickly. So that's great. So now it's just grouping by the different models and giving me the average price for each model. So if I wanted to see which is the most expensive watch overall, we can see that it's Tempo at an average of 3,254. Either that or one of them is very, very, very expensive. All right. So that's what we can do with group by. Again, very useful to get the information that we need very quickly, or to get more information depending on the different columns that we have. But it turns out that we can actually also pivot. So again, pivoting is just like doing both the grouping and the aggregation at the same time, just like we do in Excel, very similar to what we do in Excel. But the big difference is that we can have some of the groupings as columns instead of having them as rows. So we can just reshape our tables just like we did pivot tables in Excel. So let's say that we actually wanted to see the average price. So again, the price up here, or because that's the values in here of each model per condition. So here are the models, they become the rows, and then the conditions become the columns, and then the data just becomes the average price. So again, this is a pivot table, and again, you've done it. So imagine this is just like moving condition into columns, model into rows, and then average price into values. That's exactly what we're doing over here. So just like with Excel, what we do when we pivot is we're actually summarizing numeric columns by groupings. In this case, we're just grouping by condition and model. And there's every single cell is just the connection between whatever model and whatever condition. So the way to do this is we're going to use the pivot table function. So again, in this case, PD, we start with PD, pivot table, okay, because this is a function that comes from the library. So we're going to use PD. Remember, we're calling the pandas library. Then the function called pivot table. Then inside, it takes a few arguments. First argument is my data frame. So which is the data frame I'm pivoting? And then the rest is going to look a little bit more commonplace. Then the values. So what are the values that I want to add in here? In this case, what is the numeric column that I'm using? Then the index. So in other words, what is the row variable? So what do I want as rows? And finally, columns. In other words, what do I want as columns? So think about it the same way when we were doing pivot tables in Excel. Okay, this is your formula. So by the way, here's the documentation. I'm actually going to share it. Here's the Pandas documentation. And because it's always great to practice using documentation, I'm sharing it on the chat. And what I want you to do is actually use this information and whatever you can find in the documentation that I just shared with you to build this table. So how would you build this table? And when you're done, either share with me the table you got as a result or the code that you used to build it. And that's it. And I'm going to give you about 5 minutes. I'm trying to get everything inside. All right, so let me actually make it a little bit smaller just so everything fits. Okay, so here's the table and here's the exercise. So the idea is to recreate this using a pivot table from the pivot table function from Pandas. Jennifer, my DF just means what is the name of your data frame? We've been using DF just in case. I forgot to start the timer and you're all very fast. So, all right. So amazing job, everyone. So apparently Pandas definitely Pandas has some ease of use. In other words, it becomes, and the more you use it, it becomes more and more intuitive. But let's actually do this one in particular. So I'm actually going to use this. I'm actually going to copy and paste the code that we have over here. So again, I just changed my DF to DF because that's the name of my data frame so far. Now, what is the numeric column that we want to use is price. The row variable in this case, I believe is, rows are conditions. So I'm going to use condition. And my columns, actually, no, this is going to be model. My rows are model and my columns are condition. And if I didn't make any typos, I should actually get the same that we got up here. So yeah, we got the price over here. Then the condition is our columns and the model is our rows. So again, very important. The default is going to be the mean. So this is the mean or the average. And there, so go through the documentation. If you want to do anything else, you can get the mode, you can get the median, etc. So Drew, so actually you are aggregating values on the pivot table. So this is automatically the mean only because the pivot table function defaults to mean. But you can actually, if you go through the documentation for pivot table, it's actually just, now we have time, so let's take a look at it. It's very, very important to remember how to use this. So I can actually look for pivot. So here it is, Pandas pivot table. So here's the information. And let's the median, no, mean. So it says, see over here, it says aggregate function mean. So let's actually look for what aggregate func options we have, because there should be more. So aggregate function, one. So here it is. So we have, for example, sum, you can use median, you can use mean. So yeah, you can change whatever function you want. You just have to use this particular value, which is an optional argument. So for example, if I do agfunc equals sum, this should give me the sum instead of the average. I believe median will also work. And if you want the median, you just change it to median. So the whole thing is that this, you don't need to add it. If you don't add it, it's just going to default to mean. But yeah, you can aggregate anything you want. You can define what aggregate function you want to use. All right. The other thing that we can do with Pandas is we can actually set or remove indexes. So if you remember, so this is our original data set. We have the indexes 0, 1, 2, 3, 4. But we can actually set the index to anything we want. So let's say that we don't want the indexes to be the numbers. We have something else. Let's say we have unique numbers. We have ID numbers. We have client numbers, anything that we have that is for us, and we prefer to use that instead of the indexes. We can just, that would probably show up in the first column. Let's say customer ID. DF set index. So in this case, I'm going to use set index and set the model as my new index. And then I'm going to run DF head. So when I do this, as you can see, it got rid of the numbers 0, 1, 2, 3, 4. And now the model becomes the index. Now, generally, you would never use something like the model for indexes because it doesn't make sense and because they're supposed to be unique IDs, or that would be best. But you can definitely do that. But for example, if you had customer ID, transaction ID, something that's unique to your company, and you want to get rid of the indexes that are going to build automatically by the Pandas data frame, you can actually just set that column to the ID. And if for whatever reason you mess up, that's not the column that you wanted, you can just use the reset index function. So df reset index, and I run it again. And as you can see, we're back to normal. Now the model is no longer the index, and the index is now the regular index. Again, you would never use a column like model for that, but think about most of the data frames or tables that you've been working on, databases in SQL, that they all have a unique ID, customer number, transaction number, things like that. And those can be transformed using this set index to the index of your data frames when you're playing around with Pandas. All right. And again, the other thing that you can do is you can actually index the data set with more than one column. So for example, I'm going to set the index to model, store, and condition. And then run df head. So now I have the combination of model, store, and condition as the new index. And those three columns become the new indexes. Now, again, it depends on what you have to do, but just to give you a real world example, let's say that you have a data set of people and transactions that you want to put together, and you want to have the combination of the user and the transaction ID to be the index number for that particular transaction. You can just join them together, and that actually works. Or let's say you have something like a national ID number plus a social security number, and you want to put those two together, or driver ID number, etc., and you want to join them together as your new index. So those are things that can be done. All right. Now let's talk about something particular called unstacking. So unstacking is another very cool and interesting thing we can do with Pandas. So let's take a look at our original data set. So remember, we changed it over here. Okay, so now we have the ID is model, store, and condition. Okay, so we have 75 rows and 2 columns. Remember, 75 rows we always had, but now since these 3 columns are the index, we only have 2 columns, engagement and price. So let's say, so again, we have 75 rows, we have 2 columns, we have 3 index columns, so 5 in total, but right now we only have 2 actual columns. And we actually sometimes we want to reduce the number of rows without actually removing any data points. So with pivot tables, we're actually aggregating data. So we're removing some of the data points. Sometimes we want wide data instead of long data. So again, we want to get rid of rows and we want to expand our table into more columns. And the way to do that is using unstacking. So I want you to think about it like this. So let's say that we have a condition as a single column, and it makes it difficult to find the specific thing that we want to find, the specific condition for a particular watch. So we want to transform these new, etc. So the condition column, the values, we want to transform them into actual columns so that it's a lot easier to read or a lot easier to find something. So again, we're transforming the data from long to wide. So when we unstack, what we're doing is we're taking the index, the innermost index, in this case condition, because this is the innermost index, because we have 3 columns as indices. No, we're not supposed to reset the index at this point, David. If we do, this isn't going to work, and we'll see why in a bit. So it's going to take the innermost index, which in this case is condition, and it's going to turn it into a column of its own. All right. So the data frame is going to get rearranged. So instead of having 75 rows, it's going to get a lot more columns and a lot less rows. All right. So let's actually unstack it and see what happens. So I'm going to do df.unstack and see what happens when I run it. So now the values in condition got moved out into new columns. So now I can see the model over here. Remember, model right now is an index, store as my second index, but then condition just moved into columns. And now I have a set of columns for engagement, for fair, good, like new, and very good, and for price, fair, good, like new, and very good. But here's the interesting thing. Because we just made our data wide instead of long, if you can see, this is the whole data set right here. But now I no longer have 75 rows. I have only 15 rows and 12 columns. So for example, if I wanted to see the clepsydra watches and the price, the average price for very good condition, I can just go over here and I have, price 78, super deal 77, watches unlimited 80. All right. And I actually get this. This is the original data. I'm not actually changing the data. I'm actually getting the original data from our data set. Sorry, this is very good is engagement. Prices is over here. Fair, price, or very good, 831, 4,239. So it turns out that this makes it a lot easier to read in certain cases. But the reason I'm doing this and stacking instead of doing a pivot table is because I don't want to lose any of my original data, which I don't here because I'm not aggregating. Okay. And that is the big thing and the important thing about stacking and unstacking in this case. So here's an interesting question. For you, from what you've seen so far, what is the big difference between pivoting and unstacking? Because we already did a pivot and now we just did an unstack. Yep, I'm scrolling up right now so you can see the whole table. So here's something cool. If you've ever played Dungeons and Dragons, you've seen a lot of unstacked tables. Because that's the way we work, because we want to see all of the information in a very short space instead of having a long list of things. Yeah, so that's the thing. So yeah, pivot tables, and I'm going to go up here to our pivot table. Pivot tables, as you can see, no, that's the indexes. Give me a second. Here we go. So pivot tables reshape all of our data and they aggregate. That's very important. That's great for some things, but this is aggregation. In other words, I am not seeing here my original data. Here, I'm just, and somebody said it very nicely, we're reshaping the data. I'm keeping all of the same data. I'm just rearranging it so that we don't have that many rows, but we have more columns. And that makes it sort of easier to read. So again, I just want you to think about, so if I was looking at the sand watches, and I wanted to see, okay, the sand watches on new condition. So I can see, here's the sand watches and national traders for 816, 604, 55. So it makes it a lot easier to find the specific data point that you're looking for. So there's a lot of times where we want to reshape the data. And that's what we're doing with unstacking. All right. Now, if we can unstack, which is what we did, we can restack. So that's what we're doing. So stacking is just the reverse. So remember, we have this. Remember, we had our data set with three sets of indices, three columns as indices. Then we unstacked it, and one of those indices became columns. So now we're restacking it. So all we're going to do is we're going to, where do I have it over here? df unstack. Okay, so I'm actually going to do my unstack df. df unstack, I'm just creating a new one, and my unstack df head. So this is, if my original data set unstacked, this is the original one, okay? So now we want to unstack it. We want to make it the same. So actually, let me do one more row over here, just so you see exactly what's happening. Because so this is, let me run it again. No, we're doing the same thing. So here I'm unstacking it. So my original DF, I'm unstacking it. That's it. And now I'm printing it out. Okay, so I'm unstacking it again. And now I want you to restack it. So how do you stack back what we just did? So here I'm just unstacking it. Unstacking this data set, which is the one that we had. How do I stack it back? What code would you use to stack it back? So yeah, that's it. We just use dot stack. And as most of you are putting, since this is my new data frame, my unstack df, and I'm just going to run the dot stack function back. And let me just print the head. Oops. Wow. Let me just remove this. There you go. And there it is. Whoops. Unstack df.head. I actually got the same thing. There you have it. Sorry. There you go. And then I'm going back again to having model, store, and condition back to the original form. Yeah, the dot stack function. So again, the important thing with stacking and unstacking is that it's actually going to help us reshape our data the way that we want it. You'd be surprised, especially for certain data sets, that we actually want to do this, especially when we're trying to look for a particular number, or even when we're doing reports and you want to find something specific. Yep. Wow. And you want to look for something specific and make it easier to find what you're looking for without having to go through a lot of rows. Now, again, it's going to work depending on how long this data becomes. If you have, like, for example, if condition had too many options, instead of 5, let's say the condition had 120 options, then it will become incredibly wide, and that poses its own challenges. Hank, that's a really good question. So it turns out that there's no, so here's the thing. This order, so the issue is because these are strings, all it's doing is organizing them alphabetically. So think about it. Pandas doesn't really know that fair is worse than good, and new is better. Well, we consider it better. Here's an interesting thing. If you look at this data, are new watches better or worse than good watches or fair watches? Juan, just in case, go back to the code over here. Make sure that this is what you have before you start stacking and unstacking, because that only works if we've already used these 3 rows as in set these 3 rows as indices. So you can always go back and start from the beginning all the way to here, and you'll get to the same point. But yeah, so here's a big question. So what's better, a new watch or a fair watch? So it's interesting because you can see some of these. So for example, light new, you have 831, and then the fair, which should be worse, is 4,165. It depends on the store and it depends on the watch. So it really depends on many things. So again, with Pandas, it's always good to just play around with it, figure out what you can do with it, because it's very useful. And again, we use it a lot, especially if you're interested in data science. We use it a ton for everything. And by the way, one of the things that you would do, and you can actually do that in Pandas, is if you wanted to change these conditions to something that makes more sense for us, because they're ordinal data. In other words, they're supposed to have certain kind of order. We can actually change these to 1, 2, 3, 4, 5, and actually give some weight to them so that it makes sense that they have a certain order. Does this work on live data? What do you mean by live data? Data from a database in SQL? So again, so here's the thing. Whenever you're working with live data that's updating all the time, the moment you download it into a data set, into a data frame, that's it. You're downloading the data from that point in time. Now, if you build a whole pipeline that is refreshing the data and then running through all kinds of analysis, then yes, I mean, as long as it's set up to refresh every certain amount of time, then it is going to catch the live data. So think about it like when you're building a Tableau dashboard. So the moment you build a dashboard, it's with the data that you uploaded to the system. But if you set it up so that it refreshes the data, then the dashboard is going to change. It depends. More than an API it would be more like a data pipeline. But that's way out of scope because that's it getting into data engineering. But yes, there are data pipelines. All right. Let me reconnect this. Since we have a little bit of time, let's actually, first of all, any more questions about Pandas? By the way, there's a few, I'll actually share a link with you. There's a few books, like really great books about Pandas out there, because there is a lot that you can do with Pandas. We're just scratching the surface. Especially when working with really large data sets. You've already done Matplotlib, right? For visualizations in Python. So here's something really cool that happens all the time. So let me actually go back to, let me actually reload my data frame from the very beginning, and we'll do something really cool. So here's the kind of thing that you can do. Let's see. For example, you could actually remember that each of these columns is its own. Yeah, let me actually redo this, and I'll go down here, open up a new one, and I'm going to call it watches, just to make my life easier and not mess up anything else. So now we have a watches data frame, which is the same data frame that we had. So the cool thing with watches, watches data frame, is that, as you could see, so if I open this engagement, so this becomes a data series. So it turns out that we can actually plot the data series. Like if we were using Matplotlib, this is already something that I can pass on as an argument to, for example, for a distribution plot. And it's actually going to give me the distribution for the whole system. And in other words, I don't actually have to download or extract the data from Pandas, a data frame. We can actually just pass whatever information there is already in that series or inside a set of series into Matplotlib. But here's another thing, just because we have a little bit of time, and I'll share this with you. Let me, before I forget to share it the right way, to anyone with the link. Yep, as viewer, I'm going to copy it. Remember, you have to make a copy of it. I would suggest do it. So I'll share it afterwards. So here I'm just building a very, very small data set. So this is a data set that has fruit, the quantity, and the price per kilo. So it turns out that, so we already saw that if I wanted to see, for example, df dot or df root. So, what did I do wrong here? It's with a capital F. See, you have to be precise. If you miss like a capital letter, things don't work the way they're supposed to work. So let's say that, so this is fruit. We just get a data series with the names of the fruit. But here's an interesting question. What happens if I wanted to get, so for example, what do you think happens if I do df0? Because it turns out there is some indentation. So df0 is going to give me an error. But that does not mean that we can't use indices to traverse data sets. So it turns out that we have a function called lock. If I do that, look at what happens. So I just did df lock. So lock is like small for location. And I said location 0. So what's at location 0? It turns out that it's the apple. All right. So it's actually giving me all of the information from the apple, but look at how cool. It's now giving me the fruit as a row, the quantity kilogram as also as a row, and the price per kilo for the apple. And here I can actually go for everything. So df log1 is going to give me the banana. So just like if we were doing items on a list, but instead of going through the items this way, it's actually going through the items this way, going down. So here's another cool thing. So 0, we know 0 is the apple. So I'm going to do 0, 0. And I'm going to get an error, of course, because that's not what I intended to do. 0, 2. So now I'm actually going to get, oops, here it is, 0, 2. So now it's actually going to slice the list, the data frame, just like if we were slicing the list. So what does that mean? That it's going to go and take the item at 0.0, which is the apple, all the way to 0.2. But there's a little bit of a difference. As you can see, it's using the location precisely, not like when we're slicing lists. So when we're slicing lists, this should only give me 0 and 1, because it should stop right before 2. But in this case, it's giving me 2 all the way to 2. That's because the data frame actually has 2 ways of locating things. The first one is the location, and the other one is the index location. So if I use iLoc in this case, it's going to work exactly the same way as a list. Once I add the indexing, this is going to work a lot more like lists work. And that becomes really important. The other thing is that I can do 0, 2. So now I can add a comma, and what's happening here is I'm cutting the first 2 rows first, so apple and banana, and then I'm cutting just the first 2 columns, fruit and quantity. So this iLoc function, and this is just a little bit of an extra, allows you to actually slice lists whichever way you want. So for example, if you didn't want to filter, but you wanted to get, the first 3 rows and the first 10 columns, or the first 10 rows and the first 2 columns, you can actually do it with this iLoc function. And that's just a cool additional thing that I wanted to add in case we had a little bit of time. So we have a kind of random question. If you run a Python CSV through Tableau, would different variables be equivalent to different sheets in Excel? So that's an interesting question. So I don't think there's such a thing, or I wouldn't call it a Python CSV. You actually can just save a file like a data. You can actually save a data frame as a CSV using the same way we did it when we were doing for loops. Remember that we actually saved as a text file. We can actually, there are ways to just save the files, but you would be saving the whole data frame, and the data frame is one table. Now, so it wouldn't be like different sheets in Excel. It would just be like one Excel workbook. Sorry, like one Excel worksheet. Not so if you would have to save different ones to make it like a workbook. So it actually happens that if you want to, when you try to import an Excel file that has different workbooks, you actually have to tell it which workbook you want to import, because it's only going to allow you to do one. If you want to do all of them, you would have to do a for loop, but it would create different data sheets or data frames in this case. Hope that answers your question too. Does Pandas turn all the information into an array? Not exactly. So array is something different. So array is much more similar to a data series. A data frame, because of the way it's structured, is more like a table. So if you transform it into an array, you would flatten it out, or you would create a nested array, which would be much more complicated to deal with. But in general, you can actually ask Pandas to transform something to save it into a CSV file. But again, that would be a regular CSV file, which contains one table. Hope that answers your question. Any other Pandas questions? We have a couple more minutes, and if not, I'll pass it on to Juan. Oh, maybe we have a question, maybe not. All right. If there's no more questions, I'll actually share some extra resources on the extra research channel, of course, including a couple of book recommendations. And if there's no more questions, I'll pass it on to Juan in case